Hello and welcome to Physics Online. So in chapter units 2.06 we looked at Newton's first law. We have discussed there how an object that has no resultant force, or an object where the forces are balanced, will remain at rest or continue to move at the steady speed. In unit 0.7 we're going to look at Newton's second law. Okay. So introduction to Newton's second law. Firstly, we need to look at what happens to when we have two forces. Now imagine I have two people. Let's say I've got here I've got Charles and I've got Anshu, both pushing the car. Okay, they are both pushing the car in the same direction. So let's say Charles is pushing with 100 Newton and Anshu is pushing with 10 Newton. Okay, so the resultant force, the result of their forces, is the force of Charles plus the force of Anshu. Why do we add them? Because they are working along with each other and they're working together. So that would be 100 plus 10, and that becomes 110 Newton. Now, if this is more than the friction and the mass of the car, this car would start to move. And using that, we will be able to calculate its acceleration once we have the mass. But firstly, we need to look at this thing called a resultant force. A resultant force is the sum of all the forces. Okay? So what happens if Anshu started pushing in the opposite direction with 10 Newton? Are they still working together? No. Okay? So here we would see that Charles is pushing more than Anshu. So the object is still moving in that direction. So we make Charles positive and we make Anshu negative, and we subtract their forces. And the result of these two forces is now 90 Newton. So we can add up forces when they're in the same line, but when forces are pushing at an angle that is perpendicular to the motion, if Anshu pushes or pulls this way now, okay, at 10 Newton, Anshu is not contributing to the movement of Charles at all. Okay, he's pushing against the door of the car. Okay, and Charles is pushing behind the car. So Anshu's motion is not going to contribute to Charles's direction of motion. So we say that horizontal and vertical forces do not affect each other. I cannot, by pushing something horizontally, make it fly up in the air ever. And by lifting something up, I cannot make it move horizontally. These two lines work completely separately. Okay, so how does this link up to Newton's second law? Let's go to the chapter. Okay, so if we're in the chapter, okay, it says here, if an object is at rest, it takes a big force to move. If it's moving, it takes a force to go faster or slower or to change direction. Okay, so all objects have resist this change in velocity, even if the velocity is zero. This is called inertia. Okay, so the resultant force is the result of two forces. It's one force that is equivalent to those two forces. Now, if we get back to our screen or our board, so if we draw it in terms of forces, when I put Charles and Anshu there, okay, let's make a different color. If I put Anshu and Charles there, okay, the resultant force is one force with the same magnitude as both the two forces together, and that would in this case be a force like that, and we call this the resultant force. It is the same force as Anshu and Charles's combined forces. Okay, if they're in opposite directions, okay, what we do now, like we did initially when Anshu's force was in the opposite direction, we subtract these forces. Okay, so where Charles's force stops, we draw the opposite force. Okay, the reason we do this is we don't want to draw on top of each other. We don't want to do this and then go back on top of the same line. Okay, it's just a bit confusing, so we just draw it below, but where the one arrow stops, the other one starts. And then we see which one is bigger, the left or the right or the left. Okay, and we can see the one of the right is bigger. So we fill this gap, and then we decide which direction is it going to be. This is now going to be the size of our resultant force if we had to draw it. Okay, so it's going to go towards that side. Okay, so back to our textbook, and we'll see that it is the force that is equivalent to the single force, the result of the two. So basically, I could erase that and just have drawn the resultant force. And that is the result of Anshu and Charles pushing in opposite directions. It would be that much, as we calculated, 90 Newton if this was 100 and that was 10. Okay, so the result of Charles pushing this way and Anshu pushing that way, 110, is the resultant force, which is 90. Okay, back to the textbook. Okay, so how does force, mass, and acceleration link? If we look at Newton's second law, okay, Newton's second law teaches us this formula, which we'll learn and work a lot with. The resultant force is the mass times the acceleration. So let's say we have this 100 kg car. Charles is pushing this way with 100 Newton, and that's the force of Charles, and Anshu is pushing this way with 10 Newton. Okay, so what will my resultant force side look like? Okay, so see this as two sides. We know that the resultant force would be the force of Charles minus the force of Anshu. Okay, because that would be the result of the two. Now I substitute that on the left side of the equation. What does my resultant force consist of? It consists of Charles minus Anshu. On the left hand side, it's the mass times the acceleration. Now if we have all these values, we can calculate the acceleration. If we say 100 minus 10, which we just calculated before, is 100. Okay, so coincidentally is those two numbers the same, times the acceleration. And if we want to calculate the acceleration, we calculate and divide, and we find that the acceleration is 90 over 100, which is 0.9, and we use meters per second squared as we've used it before. Okay, so that's how we apply Newton's second law. It's the resultant force is equal to the mass times the acceleration. This is the formula for Newton's second law, okay, which says that when a resultant force acts on an object, the object will accelerate in the direction of the resultant force. This acceleration is directly proportional to the resultant force, meaning if it's a big resultant force, it will be a big acceleration. But this acceleration is also inversely proportional to the mass of the object. If we had to make that 200 kilograms, then the acceleration would drastically decrease. Okay, so the acceleration is directly proportional to the resultant force, but inversely proportional to the mass. If the mass is bigger, the acceleration would be less. But if the resultant force is bigger, the acceleration would be more. And I've shown you that in my Newton's second law PowerPoint presentation as well. Back to the textbook. Okay, so here they give us a few examples and how we can calculate. This is Newton's second law. Okay, now they give us a few examples here of how we can find this. If we use two trolleys and we have a ticker tape, we can test this by pulling with a certain amount of force. This is just a practical example. So what is a Newton? 1 Newton is the force required to give a mass of 1 kilogram an acceleration of 1 meters per second. Okay, so further forces can do not only have an effect on motion. If two forces or more act on something, they can also change the shape, okay, or the volume, or both of it. This effect is slight with hand objects. The effect is slight with hand objects objects, but can be very noticeable with flexible objects, hard objects, sorry, as shown on the right. Okay, so if it's a very hard object, it's not very slightly happens, but if it's a very flexible one, we can see this effect very often. I hope you have a nice day, and if you've got any questions, please let me know.